Welcome back. This is Mr. Hassan's Maths channel. I'm now answering question number 7 from the October 2022 International A-Level Edexcel Pure Mathematics P3 paper. This question here is about the modulus function, and they have got a diagram here, figure 3, and they've told us that figure 3 shows a sketch of the graph of C1 with the equation y equals 5 minus the modulus of 3x minus 22, and that 3x minus 22 is inside the modulus sign. And it says write down, okay, very important to take note of some of these phrases used. Write down the coordinates of the vertex of C1 and the intersection of C1 with the y-axis. And notice for those two questions you only have 2 marks, so 1 mark each. All right, so that should tell us, the word write down and the number of marks should tell us it doesn't involve much thinking or working out. Okay. Now, one of the things I want to develop in my students is students who understand rather than who memorize things. Okay. So I could tell you how to get the answer straight away just by looking at the equation. I'll do that first just so that, you can see. So for example, I could say the vertex is straight away. I know that the y coordinate of the vertex is 5 and the x coordinate of the vertex is going to be 22 over 3. Just by looking at this equation, I've worked that out, right? So the answer, and that's why it says write down. So part 1 is 22 over 3 for the x coordinate and 5 for the y coordinate. That's the vertex. That's the answer to part 1, 1 mark. That's all you have to do. You don't have to show any steps. But I want you to understand why that is the case, right? Now, what we can think of is this modulus sign means that the number outside it is 5. It's 5 minus the modulus of something. So you're always subtracting something from 5. You're always subtracting something from 5. And the thing that you're subtracting, this thing is always something positive, because whatever value of x you put in here, you're going to find the modulus of that thing. For example, the modulus of minus 10 is 10. So even if this came out as minus 100, you're going to have 5 minus positive 100, because the modulus of negative 100 is going to be positive 100. So you have 5 minus 100. So you're always going to be subtracting something away from 5. You're never going to have the case where it will be 5 minus, and then you'll have minus 3, for example. Because if this is modulus of minus 3, it's going to become plus 3. So you have 5 minus 3. It will become 5 minus 3. You'll never have 5 plus 3. You'll never have 5 plus something. So that means the highest it can ever go is to 5. So that means this graph will never ever go above the value of 5. That's the highest it goes. Okay, it never goes above 5. Right? That vertex is going to be 5 on the y coordinate. The y coordinate of that vertex is going to be 5. It can't go above that. All right, that's why you have 5 as the y coordinate of the vertex. The vertex means, like in this case, the highest point, because it kind of opens downwards, you could say. And we need to find the x coordinate for that point. Right? How can we find that in an easy way? Well, this expression is going to equal 5 when you take away nothing from 5. It will be 5 minus 0. 5 minus 0 will give you 5. So when this part of this becomes 0, that's when you're taking away nothing from 5. So what makes 3x minus 22 become 0? When x equals 22 divided by 3. So when x is 22 over 3, this becomes 0. You have y equals 5 minus 0. So that is when x equals 22 over 3 and y equals 5. That is the vertex. It's kind of like if it was y equals 5 minus 3x minus 22 squared, like a complete the square kind of thing. If it was like this, you would get exactly the same answer for the vertex. Because here, you're always subtracting something positive from 5. So it's 5 minus something always. And the least you can subtract from 5 is when this bracket becomes 0. Well, why is this always positive? Because it's squared. It's kind of similar to this. It's always positive because the modulus of something will be positive. When you square a negative number, it becomes positive. So you're always subtracting something away from 5. And the least you can subtract from 5 is 0 when this bracket becomes 0. So 5 minus 0. What makes this bracket 0? X equals 22 over 3. So it's very similar to finding the vertex of a quadratic. Okay, that's why it's like whatever's inside the bracket, okay, with the opposite sign. But in this case, we'll say also that, whatever makes the bracket 0, basically. Whatever makes what's inside the modulus sign 0. So when x equals 22 over 3, this becomes 0. That's the x coordinate. And whatever's left on the outside, the same as it is, like the 5, that's the y coordinate. Okay, so that's the understanding behind how to look at the equation of the modulus function and write down the equation of the vertex straight away. Okay, and then it says the intersection of C1 with the y-axis. Now we know that something hits the y-axis. As we know, the y-axis, everywhere on the y-axis, x is 0. The equation of the y-axis is x equals 0. So if we want to find where something crosses the y-axis, and this is going to cross it over there somewhere, all right, we have to replace the x with 0. So we take the equation and just simply replace the x with 0. When x equals 0, you have y equals 5 minus the modulus of 3 times 0 minus 22, which is 5 minus, you have minus the modulus of negative 22. Now remember, the modulus of negative 22 becomes positive 22, so it's 5 minus 22, which is going to give you negative 17. So the coordinates of the vertex are, or the y-intercept in the section with the y-axis is 0 and negative 17. And we can see that kind of looks sensible. That's on the negative side. All right, so we have now got the vertex, okay, and the y-intercept, basically. That's part A done. Now for part B, it says find the x-coordinate of the intersection of C1 with the x-axis. Now, the x-coordinates, they only want the x-coordinates of the intersections of C1 with the x-axis. Now, the x-axis is where y equals 0. So we can simply just make this equation equal to 0. We can say, okay, when we replace this y with 0, we end up with 5 minus the modulus of 3x minus 22 is equal to 0. When you rearrange this, you end up with basically having the modulus of 3x minus 22 is equal to 5. Okay, you can just add this whole thing to both sides. Now we can say, okay, if we want to solve this, what does this actually mean? This means if the modulus of something is equal to 5, it means that thing, which is inside the modulus sign, can either be 5 or it can be negative 5. Okay, so if the modulus of something equals 5, that means that thing could have been 5 that you put in here, or you could put negative 5 in here, and it would become positive 5. So 3x minus 22 could either be 5, or it could be negative 5. And in this case, we're going to have 3x equals 5 plus 22, which is 27. So x equals 9. So that's one of the answers. They only want the x coordinate. So that's going to be here, 9. Well, we don't know yet, actually. We have to figure it out. In fact, it must be there because this point is 22 over 3, which is less than 9. So yeah, 9 must be there. Again, this must be less than 22 over 3. Let's see. So you're going to have 3x is equal to minus 5 plus 22, which is 17. So x equals 17 over 3. So that's the other point. 17 over 3, which is over here, which is like 5 and 2/3. So yeah, it is less than, well, of course, it's less than 22 over 3. All right, so there we have the x-coordinates. They only want the x-coordinates of the intersection of C1 with the x-axis. We could have also done this in a slightly different way. We could have said, okay, the positive argument of this, okay, when you treat the modulus sign as if it's just a bracket without doing anything, is going to be y minus 3x minus 22. Y equals 5 minus 3x minus 22, which will give us y equals, that's going to be minus 3x and 5 plus 22, which is plus 27. So that would be this equation. That would be this graph. This would be y equals minus 3x plus 27. And this would be when you treat it, it's like you have the modulus sign, but you change the sign outside it. That's going to be the negative argument. Whatever sign is outside it, you change its sign. So it's 5 plus 3x minus 22, which is y equals 3x minus 17, which is this line, of course, and we already know it goes to negative 17, as you can see there. So that's 3x minus 17. So you can say that's the equation for this. So when does this equal 0? When does this hit the x-axis? When y is 0. When y is 0, you're going to have 3x equals 27, x equals 9, which is what we got. And when y equals 0 here, you have 3x equals 17. So x is equal to 17 over 3, which is what we got there. So we could do it using the definition of modulus, or we could do it using, that's the positive argument of this graph. So that's this part of the graph, and we find where that hits the x-axis, and this is the negative argument of the graph. So we'll see where this hits the x-axis, and we get the same answer. So there's two alternative ways of doing it. One like a graphical way, the other one an algebraic way. And both are perfectly fine in this case. All right, now, for part C. It says diagram 1 shown on page 21 is a copy of figure 3. So I put the diagram here, all right? We got to, on diagram 1, sketch the curve C2 with equation y equals 1 over 9 x squared minus 9. Identify clearly the coordinates of any points of the intersection of C2 with the coordinate axes. So now, we already know that this is the point 9, and this is the point 17 over 3, and this is the point minus 17. Okay, and we also know the vertex, but no need to show that thing here. So now we've got to draw on the same axis y equals 1 over 9 x squared minus 9. And we've got to show where this curve crosses the axes. So this is a quadratic, and it's a smiley face, like this. It opens upwards. Positive x squared means it opens upwards. So we know it's going to have this type of shape. Let's see, where does it cross the y-axis? It crosses the y-axis when x equals 0, which is going to be when y equals minus 9. So that's going to be 0 minus 9. So it crosses the y-axis somewhere over here. I'm not going to mark the point until I've drawn it. And where does it cross the x-axis? Okay, let's solve the equation where 1 over 9 x squared minus 9 equals 0. Let's multiply everything by 9 to get rid of the fraction. So you have x squared minus 81 equals 0. So you have x plus 9 and x minus 9 equals 0. So x equals minus 9 and x equals plus or minus 9. So basically it crosses here and also almost the same distance on that side, exactly the same distance on that side, minus 9. So 9 and minus 9 is where it crosses the x-axis. Okay, so I've got enough information to draw it now. So I'm going to get rid of this now because I don't want to force myself to go through. I need to go through this point here. So I'm going to go through the 9. So I'll start drawing this way, quadratic. Okay, and I'm just going to draw a quadratic. I'm not going to worry about making it go through anywhere. It's not bad. Okay, so now I know this is negative 9, and I know this is also negative 9 from the y-axis. So it says, identify the coordinates at any point where it crosses the x. Yeah, so if you put that's fine, it's probably better to write it as a coordinate form, but if you didn't, that's no problem. I just wrote it as coordinate form because it says coordinates, so just to be on the safe side. So that is the graph of y equals 1 over 9 x squared minus 9. Okay, so we've done that part. That's completed this section, part C. Now we've got to go on to part D. So that's 3 marks. Okay, that's fine. All right. Now it says, find the coordinates of the points of intersection of C1 and C2. So we've got to find these points here, where they intersect. Now, one of them, we can see from the graph, it's 9, 0. That's one. We can see that. This crosses at 9, 0, that crosses at 9, 0. That's fine. I don't think we need to actually show any steps for that. Okay, but for this part here, I want to find the coordinates of where they intersect. Now, what I can do is, the way I would do it, I would say, okay, let's take y equals 5 minus the modulus of 3x minus 22, and I know that it intersects in this section when they have in fact, you know what I'm going to do? I'm going to show how we get both of the answers, how we get this and this. Okay, so let's look at the positive argument for just in case you get a question like that. So let's look at the positive argument of this curve, of this graph. The positive argument of this graph is this section, as we mentioned before. How do you find it? Well, you just replace the modulus sign with a bracket. So you leave everything as it is and just write this with a bracket instead of a modulus sign, and you just write down what you get. So you have 5 minus 3x, you have minus 3x, and you have 5 minus 22, that's minus 3x plus 27. That's the equation of this curve. Okay, so we want to find where this meets with this graph, but I'll also find first a negative argument so I can do everything together. So the negative argument of this is going to be where you change the sign in front of the modulus part and then change it into a normal bracket. Okay, that's how you find the negative argument. So whatever sign that was in front of the modulus, you change it to the opposite sign. So this is going to give you y equals, and you'll have 3x, you have 5 minus 22, which is negative 17, which is the argument of this side of the graph. Y equals 3x minus 17. That's the negative argument of the graph. Okay, now we want to see where they both intersect this curve. So we have x squared, we have 1 over 9x squared minus 9. Let's see first where it hits this, which is minus 3x plus 27. This one shouldn't be too difficult. So we have We have 1 over 9 x squared, and we have plus 3x minus 36 equals 0. So let's multiply everything by 9. So we have x squared plus 27x, and you got 36 times 9. Gives you 324 equals 0. So to solve this, I know one of the solutions is x minus 9. I know that for sure. So let's do 324 divided by 9, see what we get. I didn't actually have to do this one because we know they intersect. That's 36. That's going to be x, it's going to be plus 36, of course. So we have x equals 9, and we can see that when you subtract them, you get 27, you multiply them, you get that. So x equals 9, and x equals negative 36. Now, one of those solutions is not actually a solution, okay? Why is it not actually a solution? Because we're finding where this graph hits this curve. Now, what's going to happen is, this curve, this line stops there, then it comes down again. It doesn't continue up. But if it were to continue up, which the equation that we're solving actually takes into account, which we don't want to take into account, if you continue drawing this upwards, eventually this is going to get steeper and steeper, and they're going to meet somewhere, and that's where x equals this value, which is negative 36. So we don't want this value because it's actually not a real value. It doesn't actually meet. They don't actually meet because this comes down again. It doesn't go up. But the equation that we're solving, this equation, is where this line meets this curve. We don't think, when we're solving this equation, there's no modulus we're thinking about here. So we have to get rid of this solution that doesn't make sense. And you could work out that it doesn't make sense visually, or you can work out it doesn't make sense by putting it back into this original equation that we started to solve, where you equate these to each other. You equate this to this. If you put x equals negative 36 into this equation where you equate these two together, you'll find that it makes some sort of contradiction, makes it not true. Okay, so it says, the question says find the coordinates of the point. So the x coordinate is 9, and of course the y coordinate is 0. That's on the x-axis. So that's 1 point. Okay, we didn't actually have to do that. I don't think so, because we know they both pass through 9. So that was just a bit of extra stuff. Now, we can also look at the negative argument of the curve, which is 3x minus 17. Okay, we just looked at the positive argument. Now the negative argument. So I'll just make a little line here to separate them. So we're going to look at the negative argument. This is where you have 1 over 9 x squared minus 9 equals, and the negative argument is 3x minus 17. Okay, so we want to solve this to find this point here where they intersect. Okay, so we can, we can multiply by 9 first to get rid of the fractions. In fact, no, what we'll do to make it easier, let's just bring everything to one side first. So you have 1 over 9 x squared minus 3x, and you have minus 9 plus 17. Minus 9 plus 17, which is going to give us, let's just make sure, you have 9 minus 17. That gives us minus 8. So it's going to be plus 8 equals 0, right? Minus 9 plus 17 is plus 8. That's right. So now we can multiply by 9. So we have x squared minus 27x plus 9x is 72 equals 0. Now we want to factorize this. So you have x and x. So two numbers multiplied to give us 72. And when you add them, you get negative 27. They're both going to have the same sign, both negative. So we have 9 times 8, we have 36 times, let's look at all the ways of getting 72. We have 72 divided by 2. That's not going to work, I think. 36 and 2, we want 27, no. 72 divided by 3. 24 and 3, that's the one, 24 and 3. X minus 24 and x minus 3. So we can say x is equal to 24 and x is equal to 3. So there we have the two solutions. Now, which one of the solutions are we looking for? Of course, we're looking for the solution over here. That must be where x equals 3. Okay, that's the x equals 3 part. X equals 27, where does that come from? Or 24, sorry. Well, that's if we considered, similarly to what we just did now before, if we were considering this part of the line, okay, if you continue drawing it, it's going to continue going up and up and up and up. And this curve will continue going up and up, getting steeper and steeper. Okay, eventually they'll meet somewhere, and that's where x equals 24. But we don't need that because our curve stops over here. So both of these branches, we don't need them. Okay, so it's not actually going to intersect because of the modulus sign. The modulus sign means it goes down, it doesn't continue on. So there's no, the only real solution is going to be when x equals 3. This one, we reject it. So we're going to find what y is. So we can easily find that actually by using this equation. That's better. It was this equation, y equals 3x minus 17. It's a bit easier to use, I think, than using the quadratic, although it's not such a big deal. That's going to be 3 times 3, which is 9, minus 17. So I think that's going to be negative. Is that negative? Yeah, it's going to be a negative something. So that's 3 times 3, 9, 9 minus 17. Okay, so let's see. 9, take away 17. That's going to give you negative 8. Okay, negative 8. So the coordinates of this point are when x equals 3, y equals negative 8. That's the other point. So those are the 2 points of intersection of C1 and C2. Okay, algebraically we're getting 4 points, but we have to think about what those points actually are. Okay, there's 1 point that would have been formed over here where the curve continues on and meets this line. And the other point, which we don't want, sorry, up in there. The other point which we don't want is where this line would have continued on and meet the curve as it goes up there. We don't want those 2 points. We only want these 2 points here, which we found. Okay, and that's the end of this question number 7, I think. Yep, that's it. So that concludes question number 7 from the P3 Edexcel paper from October 2022 International A-Level. Other questions from this particular paper can be found in the playlist that will appear in this region of the page, end of this video. Other questions from P3 modulus functions can be found in the playlist that will appear over here. You can subscribe to my channel by clicking on this link, and you can watch the video, the link for which will appear over here, which will show you how to use my channel to access information or access videos that will be useful for you. Thank you for watching, and see you soon.